Question 13 is a circle theorem question. S and U are points on the circumference of a circle that has a centre of O. ST, that's that line, ST, and UT are tangents to the circle. I've seen that word tangent, and even though I don't know what they're asking me to find, I'm thinking, and so should you be, a tangent, that's got something to do with 90 degrees. I'm going to read on. So we've got some tangents. Then they say angle STU is 42 degrees. Work out the size of angle SOU. SOU. That's that angle. So that's what I need to find. Angle SOU. Now, there's not an awful lot of information given to me here, and this would be almost impossible to answer if you did not know that a tangent is 90 degrees whenever it meets the radius of a circle. So that's where the tangent meets the radius. That's 90 degrees. Here we have another radius, and there's a tangent, so that there's also 90 degrees. So what I end up with here is a four-sided shape with a 90 degree angle there, a 90 degree angle there, a 42 degree angle there, and that one is unknown. Now, a four-sided shape always sums to 360 degrees. So in order to find that angle, I just need to subtract all the other angles from 360. But first of all, I'm going to provide the examiner with some reasons of how I can get to those numbers. So the first thing I realised is that angle OST is equal to angle OUT, and they're equal to 90 degrees. And the reason is because tangent meets a radius at 90 degrees. So for stating that, I would get a method mark, and I would get part of a communication mark for that reason. I need the second reason in order to get the full mark, but that's the first part. So now I'm going to show that I'm aware that I use 360 degrees, I subtract the 90, and the 42. So subtract 90, subtract 90, subtract 42. That's going to give me 360, take 90 is 270, take 90 is 180, take 42 is 138 degrees. And so that's what my angle is. So I'm going to finish it off by calling it what they wanted. It's called angle SOU. So SOU equals 138 degrees. In order to pick up the second communication mark here, I need to provide a reason for how I got there. And that is that angles sum to 360 degrees in a quadrilateral. So angles sum to 360 degrees in a quadrilateral. So there's one mark for getting the 90 degrees. I get a communication mark for my both reasons, and I get the final answer mark for stating clearly that my angle is SOU is 138. Question 14 is a surds question, and most maths teachers I know absolutely love surds because I think that they look so complicated, but they really do follow a very simple set of rules. This is asking me to express 5 root 27 in the form of n root 3, where n is a positive integer. If you are unaware, an integer is a whole number. So we want to express 5 root 7 so that it looks like that, where n is a positive integer. Now, first thing I need to do in order to address this is to understand what, I don't know why this is playing up, to understand what 5 root 27 actually means. And it means 5 times by the root of 27. Now that's still not really any use to me. Keep it in mind, I don't want that root of 27. I want it to be a root of 3. What I need to do now is break up that root into 2 other roots. And I need to decide then what 2 roots multiply together in order to give me 27. And preferably I'd like one of them to be root 3. So I need to decide what times by 3 is going to give me 27. And that's 9 3s are 27. So now I've broken that root 27 up into root 9 times root 3. I can add in the fact that it started with 5 times by root 9 times by root 3. Knowing what I know now about numbers, I know that the square root of 9 is 3. So actually what I've got is 5 times by 3 times by root of 3. Now I can't multiply these by that root of 3 because they don't have a root. But what I can do is 5 times by 3, which is 15. And I'll end up with 15 times by root 3. And just like in algebra, if I had 15 times by x, it would be 15x. With surds, I can write it as 15 root 3. Now sadly, that is only a 2-mark question, even though it was so satisfying to do. But you get one of those marks for breaking the surd down into its factor pair, and you get then the answer mark for recognising it would be 15 root 3. For part B, they want us to rationalise the denominator, and in order to rationalise the denominator, you need to understand first of all that a denominator is the bottom number of the fraction, and in order to rationalise it, I want anything there other than a root. I do not want a root at the bottom of my fraction. I don't mind what's there, I just don't want a root. So how can I get rid of that root? Well, I've got 21 over root 3. If I've got a root of anything, I can very easily make it a whole number just by multiplying by itself. So if I do root 3 times by root 3, I know that's going to end up giving me 3. If you don't know why that is, you need to go away and revise this. You need to go away and revise surds and the rules of surds. However, basic rules of fractions say if you do something to the bottom, you have to do it to the top. So I must remember to times the top of my fraction by root 3 also. So that means for the top of my fraction, for the numerator, I end up with 21 times by root 3, which I write as 21 root 3. And at that point, I can realise that 21 is divisible by 3, and that would leave me with 7 root 3. Now, according to the mark scheme, you can get a method mark for showing that you know rationalising the denominator means to multiply root 3, and you get an answer mark if you got that or if you got that. So if in doubt with surds, if you think I'm likely to make a mistake here and I'm happy with that answer, then that's fine. You could have left it at that and still had the same mark. Question 15, negative and fractional indices. Again, another one. These are just rules that you need to learn. You need to learn them. You need to recognise them. When they come up in an exam, they're 1 mark, 2 mark questions, and you can just smash them straight away and pick those marks up. So I need to write down the value of 27 to the power of a third. And in one of my last videos, I said that I use the BRAP way of thinking about it, where I've got my big number, my root number, and my power. That's when it's a fractional indice. So I've got my big number, which is 27. Whatever the bottom number of my fraction is, that is the root I'm looking for. So in this case, I'm looking for the cube root of 27. And then that will be raised to the power of whatever my numerator is. In this case, it's to the power of 1, which doesn't actually have any effect on my answer, so it's irrelevant. I need to find the cube root of 27. If you're not great with cube roots, what a cube root is the same number multiplied by itself 3 times is going to give you 27. I could trial them if I want from 1 upwards. 1 times 1 times 1 is 1. 2 times 2 is 4, times another 2 is 8. So that's not it either. 3 times 3 is 9. 9 times 3 is 27. Jackpot. I've got my answer of 3. It's a 1 marker. And it's a B one because it's just showing a piece of knowledge. You either know this or you don't. Part B wants you to find the value of 25 to the power of negative a half. Now this is exactly the same as above. We've got a big number, we've got our root, and we've got our power. The only difference is this time we've got a negative on our power. Now the fact that we've got a negative indice, it means that our answer is going to be 1 over and then whatever you're left with. So knowing that that gets rid of the negative, I'm left with 1 over 25 to the power of a half. And I know that 25 to the power of a half is my big number, 25. My root, which was the denominator, in this case the square root, and it would be raised to the power of 1, but that doesn't have an effect. So that means my answer is going to be 1 over the root of 25, and the square root of 25 is 5. So my answer is 1/5, or if you're a decimal kind of guy, it's 0.2. And that's a 2-mark question, and you can pick the marks up for that by having the answer mark at the end there, an A1 for either of those answers. And in order to get a method mark, you would need to show that you are aware it would be, you are aware it would be 1 over, and that would get rid of the negative index. Question 16, I'm going to say it again and it's going to come as no surprise to anyone. I love these questions. I love algebra, I think, especially when it looks difficult and it's actually not entirely difficult. So let's look at this. They want us to simplify 2y minus 12 over y squared minus 8y plus 12. It's not as difficult as it sounds. The routine is always the same with these questions. You're going to need to do some kind of factorising and then something will cancel out. It always works. So I'm going to look at the top part of this fraction and I'm going to factorise it. It's in 2 parts. There is a common term in both of them, and that is the number aspect. And there are no powers, so it's not a quadratic, so I don't need to consider any of that. So it's going to factorise into a single bracket. The highest common factor, so the highest thing that goes into them both is a 2. Then 2 times y would give me my 2y. And 2 times negative 6 would give me the negative 12 I need. So there's my numerator. There's the top number of my fraction. Now let's factorise the bottom. It's a 3-part quadratic. So it's going to go into double brackets. It's got a y squared at the start, so my bracket begins with y and y. Now, it's got a positive 12 at the end, so that means I need 2 numbers that multiply together to give me a positive 12. And because they're multiplying and it's a positive, that means both my signs have to be the same. Now, they could both be positive, they could both be negative, but they have to be the same. To identify whether they're positive or negative, I look to the middle sign. Because the middle number is a negative, I know both of my brackets are going to be negative. So now for the easy part, I need to identify 2 numbers that times together to give me 12 and take away from one another to give me 8. So I'm going to start with 1 times 12. 1 and 12. So negative 1 take away 12 is going to give me 13. That's no good. I'm going to look at 2 and 6. Negative 2 take away 6 would give me negative 8. Brilliant. So I'm going to use 2 and 6. Now, you may have trialled 3 and 4 because 3 times 4 is 12, but then hopefully you'd realise -3, take away 4 would give me -7. That's not what I wanted. So at this point, I've gained myself 2 marks, actually. I've gained a method mark here for factorising the top. I have also gained a method mark here for factorising the bottom. The final mark comes from realising that I've got an x minus 6 there, a y minus 6 there, and a y minus 6 there. And that's going to end up leaving me with a 2 over y minus 2. And that there gives me my final answer mark. Do not be tempted to fall into the trap of thinking, oh, there's a 2 there and a 2 there. I can cancel those out. No, you can't. That y minus 2 is together. You can't just go and pick off the 2. But there's your 3 marks. 16b is asking you to look at some algebraic fractions and to rewrite them as a single fraction. Now be careful here, it's easy to get carried away. When I first looked at this question and then I looked down at the marks available for it because I thought it would be worth a good 4 marks, I saw it was only worth 2. And I thought that is really harsh that they're asking you to do that with only 2 marks available. But then I realised they do not want you to work the fractions out. They just want you to rewrite it as a single fraction. So don't do hours worth of work for this 2 mark question. It's only worth 2 marks. That means it's simpler than you imagine. Now, whenever you have algebraic fractions and you're adding them or taking them away, the first thing you should always do is multiply your denominators together. And straight away that gives you one of your 2 marks. So I want it as a single fraction. And the bottom of that fraction is going to be x minus 4, x plus 5. I do not even need to multiply those brackets out. We all know I love multiplying brackets out, but I don't need to because it's as a single fraction with those at the bottom. I don't mind the brackets there. So what we've done now, because we've multiplied those together, as you do when you're adding or subtracting fractions, you need to then cross multiply the denominators upwards. So it was a 3 here, but now I've got to multiply it by the x plus 5 because that's what I did to the bottom. So I end up with 3 open bracket x plus 5, close that off, take away, and I had a 1 there. I multiplied the bottom by x minus 4, so I have to multiply that by x minus 4. So I'm going to call that minus 1 open bracket x minus 4. And at that point I'm allowed to stop because I've written it as a single fraction. That's enough to get me the answer mark. If they wanted me to solve, yes, I would go ahead, expand all the brackets, recollect and simplify them, and then deal with it from there. But they do not want that. So I'm not giving it to them.